Here we have a question on the types of triangles and the words congruent and enlargement. This is a GCSE level FG question or National Curriculum level 3 and 4. So the first thing we need to be aware of are the different types of triangles. Let's have a little recap on triangles. So if we have a triangle where all the sides are exactly the same, so that's usually denoted by 3 lines, meaning all the sides are the same, and then all the angles are the same. This is called an equilateral triangle. Equilateral. And then we've got isosceles triangles, where we could have like a pointy isosceles triangle where these two sides are the same, but this side is different. The slight variation on that is quite a flat isosceles triangle where you have an obtuse angle. This is an acute angled isosceles, this is an obtuse angled. And the third type of triangle is just one where all the sides are different. So all the lengths are different, and that's called a scaling. Let's just write those down. Isosceles and scaling. And now another type of triangle that is a subtype of these triangles, not equilateral, but you can have this as an isosceles or a scaling, are right angled triangles. Really they're not a main type of triangle. This right angle triangle would be a scaling one where all the sides are different. And we could have an isosceles right angle triangle where two sides are the same. And these two sides are the same. So those are different types of triangles that we need to be aware of. But the three main ones are equilateral, isosceles and scaling. So when we're looking for an isosceles triangle, we're looking for one with the two sides the same. Now we could get a ruler out and measure these, but we're really looking for a clear line of symmetry. And this shape here is clearly symmetrical. This side here and this side here are the same. So our isosceles triangle is D. There are some that look a little bit isosceles. So this G looks a bit isosceles, but that, when you're trying to match diagonals with straight lines, they're unlikely to be the same length because these diagonals are always slightly longer than the sides. Write down the special name for F. Well, that is a right angle triangle. I really don't like to use that as a special name for F. It's actually a scaling triangle, but you would get away with putting right angled. I mean, to be perfect, it's a right angled scaling, but either scaling or either right angled would be fine for the answer, or perfectly would be both. Okay, question C. Two of the triangles are congruent. Congruent means exactly the same. So if you turn them around, they will fit exactly on top of each other. So which two triangles are exactly the same? Well, if we just go around looking for ones that have the same starting point. So this one's got a diagonal going across one square, and this one also has a diagonal going across one square. Does this diagonal going across two squares match this one? Well, it does. And then usually when you've got two sides, the third side should match. You've got going across 3 squares. So A and E are the congruent triangles. Okay, so in question D, we are told that triangle B is an enlargement of triangle A. So B is a bigger version of A. What we've got to do is write down the scale factor of the enlargement. Now the scale factor is just how many times bigger B is than A. So if I just take a little copy of A and show you that it fits nicely onto B when it's enlarged, so I make that bigger, we can see there's pretty much a perfect match for B. But how many times have we enlarged that? How many times bigger is that than A? So if I take A back to its original size, okay, so if we're looking at, there's the original A, this side here is 1, 2 times as big, this side here is 1, 2 times as big, and this side down the bottom here is 1, 2 times as big. So the scale factor is a scale factor of 2. The sides are all twice as big, so that's a scale factor of 2.